Here is Group 4-3's presentation for Lab 2, RC and RLC Circuit Analysis.
In this lab, the main focus was determining specific parameters from a set of experimental data obtained from an RC and an RLC circuit. We found time constants, natural frequencies, damped natural frequencies, and the damping ratio. Usage of various theoretical equations allowed us to obtain these values.
For the RC circuit, a resistance and capacitance decade box was connected to the computer to create a circuit. This was done so LabVIEW can control the frequency and voltage. The frequency was set to 10,000 Hz, and as LabVIEW recorded the data, the voltage was switched between 0 to 1 volt and then back to 0 volts. This data contained the capacitor and source voltage, which was then exported to be analyzed in MATLAB. The RLC circuit was very similar, but in addition to the resistance and capacitance, an inductance decade box was included in the circuit. Similar to the last time, the voltage and frequency was controlled using LabVIEW, but with the frequency being set to 25,000 Hz this time around. LabVIEW recorded the voltage changing back and forth from 0 to 1 volts, with the capacitor and source voltage being exported in a text file. Creating the critically damped system required the calculation of the system's resistance that would result in repeated real roots. After a theoretical resistance was calculated, an LCR meter was used to ensure minimal initial error. The rest of the procedure followed the same steps as the undamped RLC circuit, with the frequency being set to 25,000 Hz.
In the first half of the experiment with the RC circuit, we were able to find, as shown in the top figure here, that the theoretical and experimental data mimic each other quite closely. And this half of the experiment was used to show different ways to measure error, and this was focused around the time constant. So the lower plot shows the error fraction as calculated. There was also a visual inspection of the plot, and both of these were then compared to the actual value to talk about different ways to measure error. The second half of this experiment used two different pieces, one with underdamped roots and one with critically damped roots. For both of these, our experimental data matched our theoretical data quite closely, as can be seen from the plots. But this information, we were able to use it in the lab report to determine the different factors that can help the system avoid overshoot and other oscillatory behavior, as in the case with the critically damped